What Schrödinger found out and pointed out in 1935 was that you could have a complete knowledge of the whole without knowing the state of any one part. That a thing could be in a definite state even though its parts were not. That idea was never properly explained. People don't understand it except quantum physicists. It's not a complicated idea, but it's an idea that nobody would ever think of from the human experience that we all have. And that is that a completely, perfectly orderly whole can have disorderly parts. Quantum information is like the information in a dream. If you start even trying to share it to one person besides yourself and talking about it, you start forgetting the dream and you only remember what you said about it. Can you understand what a quantum computer can do differently without understanding about physics? Yes, because just as Shannon and Turing in the mid-20th century separated the idea of computing and information processing from the theory of electrical circuits or the way gears interlaced in an old-fashioned Marchant calculator, so the theory of quantum computing separates the essential information processing part, treating it as quantum, and it doesn't matter what kind of quantum system you use to do it. Somebody asked Faraday what the value of this new chemical they discovered was. And Faraday said that scientists are always having to answer questions of people where they, as soon as they hear about something new, they ask, well, what are you going to use it for? And Faraday says, I can do no better than to give the answer to that question that Franklin always gave when somebody asked him that kind of question, and is, what's the use of a baby? The thing is, quantum information processing is so different from what we have thought information processing is like for the last 60 years that it would be a shame not to explore it and find out what we can do with it.